Hello everybody, how are you? I am Mr. Wissam. Today we will complete a lot of questions about dynamics revision about dynamics for secondary 3 from المعاصر book. Look at with me about question number 1. If a body of mass unity moves in a straight line such that acceleration of the body is given by the relation A equal 4t plus 2. We have now A equal acceleration equal 4t plus 2. Okay, here is the measured in meter per square second, t in second. Then the change of momentum. You want to find the change of momentum of the body in the time interval from 2 to 6 is equal to space kilogram meter per second. We know the momentum, its interval about acceleration for t, and we can write outside here m from t1 to t2 because it's a function of t, acceleration function of t. Then the momentum equal m multiply integration about a dot dt from t1 to t2. It's okay, we have acceleration we can put here, and he gave us the body of mass unity moves in a straight line such that acceleration of body is given by relation here is measured in meter per second square in t in second. Then the change of momentum body in the interval from 2 to 6. Okay, unity moves in m will be 1, m equal 1 kilogram. Then delta h equal m multiply the interval from 2 to 6, and we can write here 4t plus 2 dot dt. We know m equal 1 kilogram. Then we can find the result by using calculator. About this example, using calculator, interval from 2 to 6 about unknown t to find the result, because m equal 1 2 to 6 4t plus 2 t. We can use integration here, this bottom. We can write 4x plus 2 from 2 up here 6 to find the result. The result will be 72. Okay, then the momentum will be what? Momentum will be 72 kilogram meter per second. Kilogram meter per second. It's okay. Another example, question 3. A body moved with uniform velocity in a straight line under the action of the force F1, F2, F3, then A equal and B equal. What to find A and B? We know a body moved with uniform velocity, then what? Then we know F equal 0 because we know the force equal m dot g multiply g, and g equal 0. Then the force will be 0, the total force. Okay, total force equals 0. Then F1 plus F2 plus the vector of F3 equal 0. Then we can add first projection with first projection with first projection, and the result will be equal 0, and comparing between 0 and 0. We know F1 equal 2a and negative 3. 2a direction about I and negative 3 about direction g. And we have here 6 and b. F2 and F3 was a for the direction I plus 5 for the direction j. We can write here a and 5. Okay, so 2a plus 6 plus a will be equal 0, and the negative 3 plus b plus 5 will be equal 0. Then 2a plus a equal 3a equal negative 6. We moved 6 from left hand side to right hand side, then we can write a equal negative 6 divided by 3 equal negative 2. And here b plus 2 equals 0, then b will be equal negative 2. This is the result about this example. Again, a body moved with a uniform velocity. Uniform velocity, it's meaning f equals 0, because we know f equal m multiplied g, and j will be equal 0 because g is the first derivative about velocity, and velocity and uniform velocity will be 0. It's constant. Okay, derivative about constant equals 0. Then j will be equal 0. Acceleration magnitude will be equal 0. Okay, another example. In the opposite figure, the plane and pulley are smooth. When the system moves, then acceleration equals space meter per square second. You want to find acceleration. Okay, so we can write the two equations. Here, look at here about pulley and the plane. The plane and pulley are smooth. Okay, this pulley here, and we have here weight was m, and the weight here was m, and here m. We can write here the weight will be equal mg, and here we can factorize this weight here will be mg. We can factorize it here by this sign will be theta, and we have reaction here, and mg cosine theta, and here mg sine theta. Okay, mg sine theta here, the angle was 30, so we have here m multiply j multiply half. The result will be half mg. We want to find the direction, where up or down. We know mg here more than half of mg, then the direction will be down here, and it will be come up. So we can write here two tension here to write the two equation about tension and the weight. The first equation, we can write mg here sine theta here equal t. Again, t equal mg sine theta. T tangent here about this weight equal what? Equal mg sine theta, and we have ma. Ma here subtract t, subtract half of mg sine theta equal ma from Newton. We can solve this about Newton because it's moving. Okay, system moves. Look at here, system moves. When the system moves, we will find, right, the first equation, t, because the direction up here, t subtract half of mg equal ma. And the equation about here, mg subtract tangent will be equal ma. Okay, look at here, this weight was half m. Again, t subtract half mg equal half ma. The weight multiply a, acceleration. We want to find acceleration, so we must add two equations with us. We can cancel tension with tension, then mg subtract half of mg, the result will be half mg, and we have 1 over 2 here, and 1, the result will be 3 over 2 ma. We can cancel m with m, and 2 by 2, then j will be equal 3a. Again, the weight here was m, so t subtract half mg equal ma, and mg subtract t equal what? Equal ma. If we add them, the result will be mg subtract half mg equal half of mg, and 1 plus 1 equal 2. We can cancel m with m, and j equal 4, 2 times 2 equal 4, 4a. Then acceleration will be g over 4, g equal 9.8 divided by 4. We can find acceleration about this relation. 9 divided by 4 equal 2, and the remainder 1. 18 divided by 4 equal 4, and remainder 2. 20 divided by 4 equal 5. So the result will be 45 hundredths. Again, 9.8 divided by 4, this is the result here, meter per square second. Another example, a body is suspended in a hook or of a spring skull fixed at the top of a lift moving vertically upwards, and the apparent weight of the body is twice the actual weight. Then the acceleration equal dot. We have here a body is suspended in a hook here, and we have here reaction upwards, lift moving vertically upwards, and apparent weight the body was m, t was twice the weight will be equal mg. He told us the reaction here upwards and apparent weight of the body, its meaning reaction is twice the weight, twice mg. He give us this information about this example. And upwards, moving vertically upwards, so we can write t subtract mg from unit rule. T subtract mg equal ma. It's the rule. Then we can cancel tangent here and write the reading will be 2 mg. We can cancel t and write 2 mg subtract mg equal ma, and then we cancel m with m with m, and the result will be 2j subtract j equal a. Then acceleration will be 2g subtract g equal 9.8. Then acceleration will be 9.8, and the unit will be meter per square second.